Welcome back to another tutorial on business analytics using Excel QM. In this tutorial, I'm going to talk about how to address the game theory problem in Excel QM, especially the zero-sum problem. Let's review the concept of game theory. A game is a contest involving two or more decision makers, each of whom wants to win. Depending on the number of players, sum of all players' payoffs, and number of strategy, the type of game can be different. But here, we are only focusing on two players with a type of zero-sum game. A zero-sum game is one in which no wealth is created or destroyed. So in a two-player zero-sum game, whatever one player wins, the other loses. Therefore, the players share no common interest. In this example, we have a duopoly market, two dominant firms, and they compete on the market share, and they have two different advertising strategies. We have player X with two strategy of advertising, radio or newspaper, and also player Y with two strategy of using radio or using newspaper. The way we read this payoff matrix is assuming the gain for player X or the player which is on the row, so that if player X choose X1, assuming that Y chooses Y1, then player X will gain 3 points. If player X play X1, assuming that Y is playing Y2, then player X will gain 5 points. Similarly, if player X choose X2, assuming that Y is playing Y1, then X will gain 1 point. And if player X choose X2, assuming that Y is playing Y2, then player X loses 2 points. So the method that we address this game problem is called the minimax criterion. Actually, each player tries to maximize their minimum gain. It's equivalent to the other player trying to minimize their maximum loss. So when solving the problem, player X, which is on the row, tries to apply maximin strategy. Player X aims to maximize the minimum payoff, while player Y, or the player in the columns, tries to minimize the maximum loss. So when we solve this problem, we find the minimum of each strategy for player X. So between 3 and 5, the minimum gain is 3. That's for a strategy X1. For a strategy X2, the minimum gain that player X can have is -2 here. So player X tries to maximize its minimum gain. Between 3 and -2, 3 is the maximum gain. For the player Y tries to minimize the maximum loss. So if player Y choose Y1, the maximum loss between 3 and 1 is 3. And if player Y choose Y2, the maximum loss between 5 and -2 would be 5. So between 3 and 5, player Y tries to select the minimum of these two loss. So the choice for player Y is 3, the choice for player X is 3. We call this 3 as a saddle point, and the choice that each player choose, no matter how the other player plays. We call that choice the upper value of the game for player Y, which represents the minimum amount that the second player can limit the first player's winning and gains. It's calculated as a minimax criterion. For player X, that solution is called lower value of the game, represent the maximum amount of the first player can guarantee for themselves, regardless of the opponent's move. It's calculated as their maximin. So when we have the saddle point, we call this solution as a pure strategy. If we don't have the saddle point, then we need to use mixed strategy. Let's first look at an example for the pure strategy in the Excel QM for the same problem. So we are going to click on Excel QM, open the QM menu and go for the games, zero sum. We are going to just name it as an advertisement strategy. We have two choice for the first player, two choice for the second player. Click OK. Now you can see the payoff metrics is here. I call this strategy Y1, Y2, X1, X2. I'm just copying the number from the example. This was 3, 5, -2, and 1. Now you can see that the solution for maximin and solution for minimax is both 3. So we have a saddle point. Basically, the game structure will give us the saddle point solution. If I run the Excel solver, it gives me the value of the game. That's the both upper value and lower value when we have the saddle point and we have a pure strategy. So if you don't end up with the same maximin and minimax value and there is no saddle point, therefore there is no pure strategy, we need to use the mixed strategy games. In the mixed strategy game, there is no saddle point. Players will play each strategy for a certain percentage of the time. So now we are talking about the probability or the percentage of the time that each player can choose each strategy. So let's assume that player X choose X1 Q% of the time, or with probability of Q, and choose X2 with 1 minus Q percentage of the time, or the probability of 1 minus Q. Similarly, let's assume that Y will choose Y1 with the probability of P, or P percentage of the time, and Y2 with the probability of 1 minus P, or 1 minus P% of the time. So now, the expected gain for player X is 4 times of P plus 2 times of 1 minus P, because there is P% chance that player Y choose Y1 and 1 minus P% chance that player Y choose Y2. Similarly, if player X choose X2, the expected gain would be P probability multiplied by 1 and 10 times 1 minus P. We can also calculate the expected loss for player Y. If Y plays Y1, the expected loss would be 4Q, 4 times Q plus 1 times 1 minus Q, because there is Q% chance that X play X1 and the loss would be 4 for player Y, and there is 1 minus Q% chance that X will play X2, so the loss for player Y would be 1. Same thing, we can calculate the expected loss for player Y when playing Y2. That would be 2 times Q plus 10 times of 1 minus Q. Now, we want to make sure that expected gain for the two choices for player X is equal, and the expected loss for player Y is also equal. With that logic, we can calculate the percentage of the time that player X should select X1 and the percentage of the time that player X should select X2. Same thing, we want to know the percentage of the time that player Y should choose Y1 and the percentage of the time that player Y and the percentage of the time that player Y should choose Y2. Now, if I put these two equations equal, I can calculate Q, and if I put these two equations equal, I can solve it for P. If I solve the first one, Q would be 9 over 111, and if I solve that equation for P, P would be 8 over 11, and 1 minus P would be 3 over 11. So now we know that there is 9 over 11% chance that x should choose x1, and there is 2 over 11 chance that x will choose x2. 8 over 11% chance that y1 is being chosen, and 3 over 11% chance that y2 is being selected. Since this is probabilistic, we also can calculate the expected value of the game, and that would be substituting the value of Q in one of the expected game, or substituting the value of P in one of the expected loss. That would be 3.45, and same here. So the expected value of the game now is equal, and we have a strategy which is probabilistic, but there isn't a strategy for the game. Let's look at this example in the Excel QM. So we go to the game 0. We are going to name it again as advertising strategy part 2. 2 players and 2 options for each player. Click OK. Let's insert the numbers of the payoff: 4, 1, 2, and 10. So you can see that the maximin and minimax solution are not same, so we don't have the saddle point. Now I can solve this, or solve the probability, by running the Excel software. So if I run this, click OK, you can see that it calculates those numbers for us. So 0.81 is equivalent to 9 over 11 that we calculated. This one is equivalent to 2 over 11. So basically these are the same number as we had in our example: 9 over 11, 1 minus q, 2 over 11, p is 8 over 11, and 1 minus p is 3 over 11. So this one is same as 8 over 11, and this one is same as 3 over 11. So we can see that it automatically calculates the probability, and also it calculates the value of the game for us. I hope this lecture was helpful for you guys to understand the pure strategy and the mixed strategy game, as well as learning how to address the question in the Excel QM in an efficient and easier way.